Hello, welcome guys. Hello, welcome guys to NEET Coders. So today we are going to see problem number 3000. Maximum area of longest diagonal rectangle. Okay, it's a easy level question. Let's go to the description of the function. You are given a 2D indexed integer array dimensions. Okay, for all indices I. Okay, in the dimension of I of 0 represents length and dimension I of 1 represent width of a rectangle. Means we are given length and width of a rectangle, of each rectangle, and there are n rectangles in the dimensions array. So n rectangles, n length and n width. Okay, return the area of the rectangle having the longest diagonal. We have to return the area of the rectangle which has the longest diagonal. Okay, in case if there are multiple diagonals, if there are multiple rectangles who have same length of diagonal, then return the area of the maximum rectangle. Okay, maximum area. Okay, now let's go through the examples part. I will walk you through it. Okay, now dimensions of I. Dimension, first element 9, 3. Length of the rectangle, 9 is the length and 3 is the width of the first rectangle. Now how to calculate diagonal? Just imagine it is a triangle, right angle triangle. Okay, length is given, width is given, so diagonal will be square root of length square plus width square. Okay, so now SQRT, length, diagonal length, as you can observe here, square root of 9 into 9, that is length into length plus width into width, is equal to square root of 90 is 9.487. Now they are showing it consider up to 3 decimal places, so we are going to calculate diagonal of length of diagonal of up to 3 decimal places. Same for the second one. Okay, now in second case we get 10 as a length of the rectangle, length of the diagonal of the second rectangle. Now store all these values in dictionary and calculate which is the largest diagonal present. If there are multiple rectangles with the largest diagonal size, then we compute area while looping it. Okay, in this case, in both the cases diagonal's length will be 5, and luckily in both the cases area of both the rectangles is equal, so it's not going to worry about it. Let's go to the implementation part of it. Okay, so as I said, D will store all the diagonal lengths. It is a dictionary, so it will store diagonal length as a key and dimensions of that rectangle, so length and width as its values. Means it will be a diagonal is to 2D array. Okay, now for every dimension in dimensions, find the diagonal of it. It is a diagonal, it will round. This is the square root finding function, and this round function will round up this square root up to 3 decimal places. Now check if this diagonal length is present in our D. If it is present in D, then just append the I. Means in this case 9, 3 will be appended here. If not, then D of I store as a array, as a 2D array. Now check M store value. No, instead of again looping through this dictionary and finding it, we can just compare by declaring a m value. Find the length of the largest diagonal. M will be the largest diagonal here. Okay. Now take this temporary variable t. Okay, we have to take this temporary variable t and d of m, means find the 2D array from t for this maximum length of the diagonal. Again set m to -1. We are going to use as minimum number of variables as possible. Okay, so we are going to reuse this m variable. Now the task of m is to just find the length of the largest diagonal for every rectangle. Now it's over. We have stored all these values in t, so reuse it. Again initialize this to -1, then again loop through this t, means any number of diagonals, any number of rectangles with the same diagonal length. Okay, now check how we are going to find the area of the rectangle. Length into width. This is the length, this is the width of the rectangle. Okay, now compare it with max. If m is greater, m will be restored. If I plus 1, I of 0 into I of 1 is greater than m, then this value will be kept into this. Now return m, return the value of the, so this is the accepted solution. Okay, thank you very much. Like, share and subscribe. Bye bye.